Hi, welcome back. In the previous lecture, we illustrated the tracking process as the combination of data acquisition from physical process and data sharing across multiple IT systems. This lecture will be devoted to present the technologies available for automated data acquisition so as to connect the physical processes with their digital representation. This topic is extremely relevant in the luxury industry because it is deeply connected with fighting illegitimate trade, which is the combination of black markets, counterfeiting, and gray markets, parallel import. In order to fight illegitimate trade, we are looking for technologies that are capable of both acquiring the true identity of a product, so proving that the item is genuine, as well as tracking the distribution process, so proving that no illegitimate distribution channel was used. In this regard, you should remember that gray market is a serious threat to luxury companies, as the brand owner's margin is reduced to allow the official channels to compete with unofficial ones, and also because consumers' perception of the more widely available items can be severely affected. Several technologies are available to cope with this problem, including optical, mechanical, chemical, and electronic solutions. The offer is very rich and growing as we speak. All solutions available have some peculiar capability, some being very effective in proving identity as holograms for authenticity, and some being very efficient for tracking as barcode for distribution stages. But only one technology is showing excellent performances on both aspects, RFID. Radio frequency identification is a family of technologies for the automated identification of objects, or animal, or people, by using smart tags, devices with autonomous power supply and embedded software, and resorting to radio frequency for the communication of collected or stored data. An RFID application is based on several hardware and software components: a tag to be put on the object, a reader with one or more antennas to allow and control the communication with the tag, and a software layer called middleware, which is filtering and enriching the collected data before they can be effectively moved to the back end of the information system. Several types of tags exist, depending on the power source, on the operating frequency, on the chipset capabilities and memory, with some tags more suitable for logistic purposes and some more suitable for people identification. Commercially available tags are standardized and are interoperable with different brands of readers. RFID tags have several interesting features as they have a unique identifier which cannot be copied, they enable automated reading, they do not need any line of sight, they allow for multiple reading at a very high speed, they can store a large amount of information in a quite secure way, and can be designed to be very robust, and more. Of course, these features have an extra cost and require some complexity to manage, which are the reasons why RFID has been used in very specific situations when it is all worth it. Coming back to the implementation of a tracking process, and especially for brand protection purposes, RFID proves to be an excellent technology if compared with the other ones, as it is the only one capable of being an excellent marker for authenticity and an excellent tracker for distribution flows. Let's consider the example of a luxury shoe. The tag unique identifier will work as a perfect authenticity marker, as it cannot be replicated by a counterfeiting company. Moreover, thanks to the automated reading, several checkpoints can be added in the distribution process, acquiring data about the physical flows without proportionally increasing the cost of manual scanning, and therefore increasing the level of control in the distribution channel. Eventually, if the tag is located in a so-called tamper-evident position, for example, between the sole and the vamp of the shoe, any illegitimate trader trying to remove the tag to prevent from tracking its unfair behavior would at the same time destroy the product or put the product in a tampered condition, which will affect the exploitation of the criminal act. This is possible only with RFID tags, because they are perfectly readable also from under the sole or sewn in between two fabrics, and they do not require any line of sight to work. Of course, a little bit of product redesign may be needed to adopt this technology and to enhance its capabilities. In addition, RFID tags can also collect data which are very useful for several operations management tasks, especially in the retailing activities at the store, such as inventory management and customer relationship management. The latest RFID technology is quite capable also from a privacy concerns point of view. So it is really representing a valid solution to collect data from physical operations and to move data into the digital world, from where the data sharing issue that we discussed in the previous lectures just starts. One last remark. When it comes to brand protection, technology is not a lone winner. Illegitimate trade is a complex phenomenon, both from the unfair traders and from the customer's behavior point of view. Investing in technology is necessary, has to be balanced with investments in communication, so as to explain to consumers the risk of buying fake or parallel goods, and in legal actions, so as to seek and destroy unfair competitors. All the three actions have to be carefully designed and executed to properly protect the brand.